Hi friends, welcome to Learn Data Structures and Algorithms course. In this session, we focus on the fundamentals in algorithmic computing. In this unit, we like to explore first what is an algorithm. The word algorithm comes from the name of a Persian mathematician Abu Jaber Muhammad ibn Musa al-Qarimsi. According to Abu Jaber Muhammad ibn Musa al-Qarimsi, the word algorithm is defined in different ways. From his name, Abu Jaber Muhammad ibn Musa al-Qarimsi, the word al-Jaber, which means restoring. Restoring in the sense that in case if we have subtracted a quantity in the left hand side, then we can restore the value. For example, x minus y is equal to z. This implies we can restore the subtracted quantity y in the left hand side, that we can write further x is equal to y plus z. This is restoring. The word al-mukabala, which means comparing. Comparing in the sense that we need to subtract the equal quantities from both sides of the equation. For example, when we have x is equal to y, we can subtract the equal quantities, say z, x minus z is equal to y minus z. And the word algorithm, which means more or less synonymous with algebra and arithmetic. According to Abu Jaber Muhammad ibn Musa al-Qarimsi, the word algorithm is defined in different ways. For example, here, first, algorithm is defined as a set of rules for carrying out the calculation either by hand or by using a machine. Given the set of rules which are going to be executed manually, or the rules are going to be executed using a machine, so that we can achieve the desired result. So the set of rules which are used to achieve a desired result with the help of manual calculations or by using a systematic approach is said to be the term algorithm. Second, algorithm is a finite step-by-step procedure that is required to achieve the required result. Given the problem P, we need to write a step-by-step procedure. When we trace the procedure, step-by-step procedure, we will get the required quantity as the output. So the procedure which is used to achieve the required task, that is said to be algorithm. It is a finite step-by-step procedure. For example, normally algorithm is a stepwise procedure to solve a given problem. Algorithm can be represented using a flowchart representation or a pseudocode representation. Flowchart is like a pictorial representation, diagrammatic representation. A pseudocode is normal English-like statements that can be represented in terms of a step 1, step 2, step 3, etc., step n. For example, the problem is to find the average of, to find the sum and average of 5 numbers. We need to write the algorithm, then name of the algorithm, For example, some average, then specify the external inputs. For example, the variables, say int a, int b, int c, int d, int e. Assuming that, right, these are the formal parameters to the algorithm sum average. A, b, c, d, e are 5 variables which are of integer type. Then how to write the algorithm? For example, in terms of steps. Step 1, having these parameters a, b, c, d, e, right, we can write start. Step 2, input the integer variables. Values of integer variables. For example, a, b, c, d, e. Step 3, the computational step, which is used to find the sum of these integers a, b, c, d, e. Let us write compute sum is equal to a plus b plus c plus d plus e. Step 4, sum has been computed. Next, to find out the average, we can write find average is equal to, average is a plus b plus c plus d plus e division 5. A plus b plus c plus d plus e is already computed in a variable sum, so we can use the variable sum here. Average is equal to sum division 5. Step 5, print sum comma average. Step 6, stop. These are the finite number of steps in the algorithm sum average, which requires some input variables a, b, c, d, e, which are of integer type. So given the input variables a, b, c, d, e, we need to obtain the values of inputs corresponding to these variables in step number 2. Step number 3, find the computation. Sum is equal to a plus b plus c plus d plus e. Step number 4, right, find the average. Average is equal to sum divided by the total number of inputs, 5 inputs. Then at the last step, right, we need to print the sum and average for the given inputs. Then step number 6, stop. We need to terminate the execution of the algorithm. So what is an algorithm? Algorithm is nothing but a stepwise procedure to solve a given problem. In each step, we need to clearly mention what is the operation going to be performed. Every step requires that the operation should be clearly defined in that step. So in the finite number of steps, step 1, step 2, step 3, step 4, etc., step n, we can write the corresponding operations, right? Each step defines the operations or activities. More than one operations can also be defined in the particular step. So defining, right, in terms of sequential steps from step 1, step 2, etc., step n forms, right, the algorithm. So what is an algorithm? Algorithm is nothing but a set of rules for carrying out the calculation with the help of a manual calculation or using systematic approach, systematic execution. Second step, according to Abu Jaber Muhammad ibn Musa al-Qarimsi, algorithm is defined as a finite step-by-step procedure that is required to achieve the given, or that is required to achieve the required result. Third one, Algorithm is defined as a sequence of computational steps that transform the given inputs into the corresponding outputs. So the third definition focuses on some transformation, because the transformation function, for example, we can say, right, f from x tends to y, a transformation function. F is nothing but an algorithm. What is x? X represents a list of inputs, y represents a list of outputs. Clearly saying f from x tends to y, a list of inputs are transformed into some outputs. So what we can say about f means, f is an algorithm. Algorithm simply transforms the given list of inputs into some outputs. That's what here algorithm is defined as a sequence of computational steps, as here defined for finding the sum and average of 5 numbers. The sequence of computational steps: step 1, operation; step 2, perform this operation; step 3, right, find the sum; step 4, right, compute average. So in each step, right, we are given the operation, right, that is a computational step. The sequence of computational steps, one after another. Step 1 is executed first, then step 2 is executed, then step 3 is executed. So in what order the steps are going to be executed? In the sequential computation. Algorithm is nothing but a sequence of steps. These sequence of steps are necessary to transform the given inputs into the required outputs. So he defined, right, the term algorithm. Algorithm is said to be a sequence of computational steps that transform the inputs into some outputs. Fourth definition, algorithm is defined as a sequence of operations which are going to be operated on the corresponding data structures. When the operations are executed by the data structure, when the operations are, right, stored in the data structures and are executed by a machine, automatically we need to associate the corresponding memory, that means storage. Every variable, right, every instruction, right, will associate the corresponding storage. So the fourth definition focuses on, right, the algorithm is defined as a sequence of operations which are going to be organized in the data structures. For example, in our algorithm, sum average, we have defined some variables a, b, c, d, e, which are of integer variables. And we defined a variable, right, for example, sum, as a floating point variable. Let it be float sum is equal to a plus b plus c plus d plus e. So the variables a, b, c, d, e, and assuming average and sum are floating point variables. Sum, average, these variables are occupying the corresponding system memory. So the variables are, right, associated with the corresponding system memory. Hence, algorithm is said to be a sequence of operations which are going to be organized in the corresponding data structures. Finally, right, algorithm is defined as an abstraction of a program. Abstraction, that is the simplification of a program. Algorithm is defined as the simplification of a program. Assume that we like to write a program in C language to find the sum and average of 5 numbers. We need to write a main function and we need to declare the variables, and we need to get input values of variables, then find the computational statement, implement, right? Step 3, step 4, step 5 computational statements are going to be implemented. Then we need to print the results, right? A sum and average. So we have a program here, assuming, right, this is the program, sum average, a program. The simplification of the program, right? So if anyone like to know how the program, right, operates, or what is the logic of the program, if we have the algorithm, right, simply we can understand the purpose of the program. So algorithm is nothing but the simplification of a program. Program is simplified in such a way that we need to define the operations of the program in terms of a sequential steps. Step 1, step 2, step 3, etc. Step n. Hence, according to Abu Jaber Muhammad ibn Musa al-Qarimsi, a 9th century mathematician who defined the word algorithm in different ways. First, it is a set of rules to perform the calculations, and the calculations are performed using manual calculation or using a machine. Second, algorithm is defined as stepwise procedure or step-by-step procedure to achieve the required result. All of these steps are going to be executed in the sequential order. Third one, algorithm is defined as a sequence of computational steps. That steps transform the given list of inputs into the required outputs. Fourth one, the operations are going to be stored in the corresponding data structures. That means to execute the operations, we need to store the corresponding variables, right, in terms of data structures. So variables are going to occupy the corresponding system memory. Finally, algorithm is nothing but a simplification of a program. The simplified version of a program is an algorithm, so that the execution of the program or the purpose of the program can easily be visualized by seeing the various steps in the algorithm. Now these 5 definitions can be merged into a single one. So we can write algorithm. Algorithm is an unambiguous procedure. Algorithm is defined as an unambiguous procedure which consists of a finite set of well-defined instructions each of which requires a finite amount of storage. And takes a finite amount of time to complete the execution. And executed by a mathematical machine. Such as a digital computer. This is the complete definition of the term algorithm. Algorithm is defined as an unambiguous procedure. Unambiguous procedure in the sense that it should be a clear as well as a well-defined procedure. There should be no ambiguity in the procedure. That means no ambiguity in the steps of the given algorithm. Every step must be well-defined one. It should be clearly focused. What is the exact operation or to be executed in that step? So, algorithm is an unambiguous procedure which consists of, that means we are extending, right, what is this well-defined procedure? The well-defined procedure consists of a finite set of well-defined instructions. The total number of instructions in that procedure, right, that should be a finite one. Second, every instruction in this procedure, it must be a well-defined one. So what is a procedure? A procedure consists of well-defined instructions. Second, the number of well-defined instructions must be a finite one. So finite set of well-defined instructions is nothing but a procedure. So the unambiguous procedure consists of finite set of well-defined instructions where each of these instructions requires a finite amount of storage, because the instructions are going to be executed by a machine. That stage we need to store the corresponding variables in the system memory. When we store the variables in the system memory, we should have the corresponding storage capacity. So how much storage capacity is required? That is very important. It should have the finite amount of storage. That means memory. How much memory is required means memory is concerned. Finite amount of memory is required for every instruction. Since finite number of instructions are there, finite number of well-defined instructions require a finite amount of storage in the system, and it takes a finite amount of time to complete the execution. Having n number of instructions or n number of well-defined instructions, how much time is required to complete the execution of the n instructions, n well-defined instructions? It should be the finite amount of computational time. Say 5 milliseconds, 8 milliseconds, or some t milliseconds or t seconds. It should be a finite one. When the number of instructions are executed, it should take the finite computational time. So the finite well-defined instructions require the finite amount of computational, a finite amount of storage, and a finite amount of computational time. And these instructions, well-defined instructions, are going to be executed by a mathematical machine such as a computer. This is the complete definition of the term algorithm, right? So algorithm is an unambiguous procedure, a clear or well-defined procedure. The well-defined procedure which consists of a finite set of well-defined instructions, each of which requires a finite amount of storage and takes a finite amount of computational time to complete the entire well-defined instructions execution. And the complete well-defined instructions are executed by a mathematical machine. Second term, right, algorithmic is a branch of computer science. The branch, right, deals with how to design and how to analyze the given algorithm. So how to design and how to analyze the algorithm. Algorithms can be designed in different ways. For example, divide and conquer method, backtracking method, heuristics method, a greedy strategy. A different design or different design techniques are there to design the algorithm for the given problem. Analysis, right? How to analyze the algorithm. We need to find out how much storage capacity is required. That means how much space complexity is required and how much time complexity is required, right? So space complexity analysis, right, in the sense that we need to find out the space complexity, and second one, time complexity. Space complexity defines how much computational space or memory is required to run the algorithm. Time complexity defines how much computational time is required to complete the execution of the algorithm. So the study, right, which focuses on the design and analysis of the given algorithm is said to be the term algorithmic. Algorithmics, this is the study of computer algorithms. Study of computer algorithms is algorithmics.